customer calls and asks for a replacement boiler. When you arrive, you see a relatively new cast iron sectional boiler with 4 circulators. Water is leaking from under the boiler. How old is this boiler, you ask? 5 years. Whatever you do, I don't want another of these, he states. It's a name brand boiler, and there's been nothing on the industry sites about this model or the manufacturer's early failures. Then the customer drops the dreaded, I've contacted a lawyer about this. What will you do? Welcome to Boiler Room Detective. I'm your host, Ray Wohlfarth. If you're smart, you'll leave and never return. This is a job and a customer you want to avoid. But not you. You pride yourself on fixing what other companies messed up. You also realize that whatever boiler you install will suffer the same fate unless you can figure out what happened. Okay, let's get to work. The existing boiler has 282,000 BTU input and a 237,000 BTU output. To find the proper GPM for the boiler, we divide the output 237,000 by 10,000. This should give us a 20-degree rise or delta T through the boiler. Why 20-degree delta T? That's what the manufacturer recommended. So if we divide the 237,000 BTU by 10,000, it comes up to 23.7, and you round it up to 24. The 2-story building has 4 zones, each size for 50,000 BTU, for a total of 200,000 BTU. Each zone has a circulator and a thermostat to control the temperature. Using the same multiplier, 10,000, each zone requires 5 GPM for a 20-degree delta T. I like using the same delta T for the supply and return so as not to shock the boiler. It seems like a pretty cut and dry system, but there's that whole the boiler failed after 5 years and I contacted my lawyer red flag. Normally, a cast iron boiler will last 30 to 40 years. The 4 circulators, also 5 years old, are all Taco Model 007, a long-lasting, reliable circulator. Something caused the premature failure. You start by verifying the pipe size. Both the supply and return pipes are 2-inch, which can handle 45 GPM, much more than the 24 GPM required for the boiler. The supply and return for each zone is 1-inch, with a maximum flow of 8 GPM, more than the 5 GPM we need. Next, we want to check the feet of head for the longest zone. The feet of head is the resistance of the piping and fittings. If the circulator can deliver 5 GPM to the longest piping run, it could handle the shorter zones. After pacing off the supply piping to the longest zone, zone 3, you come up with 50 feet. Now you also have to factor in the return pipe, and you add the supply and return piping, and you're now at 100 feet. A rule of thumb is that for each 100 feet of pipe will require 6 feet of pump head. Well, it's actually 4 feet of head plus a 50% safety factor. So go with 6 feet. Let's look at the feet of head required for each zone to overcome the resistance. Zone 1 is 4.5 feet. Zone 2 is 3 feet. Zone 3 is 6 feet. And Zone 4 is 4.2. The next step is to plot the pump curve for Taco 007. Zone 1 with 4.5 feet of head will pump about 10 GPM. Zone 2 with 3 feet of head will pump a little over 13 GPM. Zone 3, the long one, at 6 feet of head will pump 7 GPM. Zone 4 with 4.2 feet of head will pump 10.5 gallons. The total GPM when all 4 pumps are running is 40.5 gallons per minute. That gives us about a 12-degree rise through the boiler. That's a little low, and you may want to close some of the zone valves to get the desired 20-degree delta T. Then it occurs to you that the zones may not operate simultaneously. If only one zone calls for heat, let's look at the delta T through the boiler. To calculate the delta T, use this formula. Delta T equals BTU divided by GPM divided by 500. Plugging the numbers in, you'll see the following delta T for zone 1. 237,000 divided by 10 GPM divided by 500 is 47 degree delta T, or temperature rise. This is more than double the manufacturer's recommended rise of 20 degrees. While that's excessive, look at the delta T when only zone 3 is cooling. 237,000 divided by 7 GPM divided by 500 equals 68 degree delta T, more than 3 times the desired 20 degree delta. Assuming a desired boiler supply temperature of 160 degrees, the return water temperature will be 92 degrees Fahrenheit. Condensation will be raining inside the boiler's fire side, and the acids will attack the metal surfaces. In addition, the boiler will experience severe thermal shock due to rapid expansion and contraction due to the cold water slamming into the hot boiler water. I'm surprised the boiler even lasted 5 years under these conditions. You're going to have to come up with a plan to handle this. It may include primary, secondary piping, and some way of ensuring you have a 20 degree delta T. Thanks for watching, and subscribe if you found the video helpful. My boiler books are available at Pronto Heating Supplies in New York and on Amazon.com. My articles are included in many of these industry publications. Thanks for stopping by, and I'll see you on the next case.